Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about Starship launch 2023, or for American audience 420. So let's dive deep into it. So what we are talking about? We are talking about a Starship. Now this puppy is the biggest rocket yet. Flat out, so far in entirety of human history, nothing even comes close to this level of power. Now, the most powerful successful rocket is Saturn V, and one was a bit more powerful, but it was not successful. So Saturn V is still the gold standard, and this puppy has twice the oomph into this, meaning it's a big puppy. It's a big, strong, powerful puppy. And the core difference between this versus everything else is that this also has second stage reusable, because the whole reason SpaceX is such a big deal is simply because they figured out reusability. And to give you a context how big of a deal it is, still no company has figured it out, and they are the largest. SpaceX is the largest space launcher at this point in time. Flat out, everybody else would be like few launches a year, they're like few launches a month. So fundamentally, they made a lot of progress in terms of basically launch cadence, and the only reason is reusability. So how do you take that reusability to next level? You go to second stage reusability, because right now all they're reusing is first stage. Now they want to try to reuse second stage, and because of the limitation of the fact that you want to save some fuel for landing, inherently you reduce your capacity. So it's powerful, but not that tonnage into low Earth orbit. It cannot carry too much tonnage to low Earth orbit. To solve that limitation, it will also have in-space refueling, meaning not only it can carry a lot of tonnage to low Earth orbit, it can refuel and carry same amount of tonnage to even higher orbit. So it will not be like Saturn 550 ton. By the time it's going to the moon, it's barely carrying tons. It won't be like that. It will be like 150 ton to low Earth orbit or 100 tons. It's same tonnage to be wherever else it needs to be, because it's already at orbit, already at orbital velocity. As long as you can refuel this puppy, it's going to go as far as you need it to go without too much hassle. So that's the core dream. Now be mindful, if you're familiar with the fact of rocket industry, you must understand this is too huge. This rocket is too big. There is not that many client that need it. Even basically International Space Station parts rarely cross 30 ton. So having something that can dump 100 tons, flat out not needed. So there is no demand for something this big. So will be the first customer? First customer would be Starlink satellite. Right now Starlink is struggling severely simply because they have the technology, they have a lot of customer, but their customer growth rate is faster than their satellite growth rate. And the satellite that they are launching is useless, because they know for a fact that V1 satellite, it's a good testing ground. They need V2, but they cannot launch V2 unless they have a huge puppy like this puppy. Without it, if they have to make a small, let's say V2 mini satellites, they will be able to launch very few of them. And even with basically Falcon 9 Heavy, they may not get that much done. So they need this puppy. So this will be the first customer of Starship, would be Starlink. Then we come to the second customer. Second customer would be NASA. Now NASA has already paid for it, contracted for it, but it's very far out. It's like a later stage of Artemis missions, where Artemis human landing part, lunar landing part, would be supported by this puppy, basically Starship. So that's the second contractor, quote unquote, customer, so to say. And if this puppy does everything that we need it to do, for example, reusable second stage, actually able to refuel in space properly, full loading and all that jazz, only then we can even dream about Mars. At this point in time, when we are talking about Mars, we are just dreaming. We are smoking up weed. Right now, we do not have the technology that can actually allow us to do that. So this puppy has to become completely successful. Only then we can even dream of doing something practical with Mars, rather than just like going there and coming back. Actually going there and staying there, it requires this. So what about the test? Now test was very long documentation. You can look into it. So I'm gonna try to extract a distill out of it. So distill is pre-launch procedures, because when you are talking about something this huge, this powerful, you also have to understand this could go boom any point in the time. So there is a very corridor, that is the rocket corridor, and they have to make sure everything around that corridor is safe, meaning there is no flight path, there is no maritime navigation, nothing should be happening in the flight path. Basically any time in the place where rocket can go boom, it should be able to go boom safely. It should not get, oh, it's now raining down debris on, like, habitated area. So It's one of those things they have to clarify before they try to launch. Then you have to talk about propellant loading, because when you're talking about liquid oxygen, liquid methane, those things are good. But when you're talking about this amount of it, like hundreds of tons of it, yeah, that's a completely different ball game. We had never had any experience with that, and not to mention that did cause an issue first time they tried to do it. So figuring that part out, because you really do not want to be in a stage where it's like, I'm fueling up, and at the last moment your pumps are like, bro, I can't do this anymore. You really don't want that. So propellant loading is actually a very serious thing, especially for this huge. So they have to do that, and then lift up, successfully go off, and hopefully don't blow up the pad, ideally desirable. Then survive max q. This is the most ironic part of rocket, is that rocket is accelerating, but it's not accelerating fast enough, or it is accelerating fast, but atmosphere is not becoming thin enough, where it's like, bro, atmosphere creates a barrier around you, basically a shock wave, so to say, and it pushes down on you. If your rocket is strong, robust, absolute, it can just punch through it, which we call ICBMs. But when you're talking about something like this, these are lightweight rockets, so inherently they are designed to just caress their way. They're like, the moment they detect max q status, they're like, okay, let's throttle down the engine, let's just relax, let's take some chill pill. They burn extra fuel by doing so, but they push through max q very comfortably. Once they are outside, once they are in the quote-unquote vacuum, and they know, oh, at this point it's pure vacuum, they go all out. So that's how they compensate for it. So they will have like throttle as high as it can go, and then max q, it's like relax, relax, relax. But they will wait for a few kilometers for max q to dissipate. Once it dissipates, they know now we can go YOLO. Then the throttle comes on 100%. So survive max q, then do main engine cutoff, because again, starting that many engine, that's one thing. You have to also make sure that you shut them off safely, and not to mention you requires a restart, so it's a very tricky thing. So main engine cutoff, do stage separation, do booster boost back a run, and then Starship should be ignited at this point in time. Starship should do orbital climb at this point in time. Booster should land, basically come back and land, or try to do so, and then you have Starship basically trying to do an orbital climb, but it's inherently designed in such a way that it will not go into orbit, meaning if they have a failure of computation or whatever have you, it cannot get stuck in low Earth orbit. It cannot go there. It does not have that much delta V. So it will go there. It can at best can only do 1 or 2 orbits. So and that's it if no intervention is done. So it will do 1 orbit, and then it's gonna do atmospheric re-entry, and that's the most critical aspect, because they need to test the heat shield, puppies. The heat shield is the biggest gamble that they are taking, so they need to test that, and the only way to test that is at orbital velocity. So atmospheric re-entry is the critical aspect. After that, just do a Pacific impact, because again, they have not sorted landing part yet. It will take some time, but just test out the heat shield and give all the data, like go YOLO on the data. Basically give server full of data, server full of telemetry data, as much data as you can. And doing an actual real world test is what we classify as weak point finders, meaning you think that it will work, because how do you know? You don't. You are just relying on CAD data, you are relying on computer modelings, simulations. Those are good, those are not useless, but they're not perfect. You may still have a weak point that you do not know, or you are not aware of. So this sort of actual launch will supposed to tell you weak points, where it's like, bro, this part barely works, this part you are lucky that it worked. So weak point data is also very important. That's the only way you can make sure that Mark 2, Mark 3, Mark 4s are robust, puppy, rather than just like barely working to be like, bro, I got this. You always want, bro, I got this. You never want like, barely working. So that's the test. So what were the flight when they actually launched this? Well, it took off and things went bad. 3 engines failure flat out. The moment they launched it, it had engine failure, and more engines started to fail. If you watch at multiple streams, multiple people were streaming from multiple camera angles, so you can notice literally in different streams you can see one engine going boom, another engine going blah, 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 and like literally multiple engines failure did happen as it's trying to go up. So this was the reality. Basically, not all engines are lit, because again, multiple engine failure did happen. And it's not like, NASA was basically SpaceX was hiding. Even in their telemetry data, it's like, yeah, multiple engine failures were detected. Now you may be like, okay, failure happened at launch, it happened, then why the heck it kept going up? Because if you take all engine as one unit, it only needs 70% of the thrust to do everything it needs to do. So it had so much redundancy. So if an engine failure is detected, it can throttle up other engines to compensate before it reaches a point where it's like, bro, I can't do anything. So there was a lot of margin. That's why even with that many engine failure, it successfully did what needed to do. Basically, from a booster point of view, this is like, bro, we got this. Like, it did everything it's supposed to do with engine failures. Whereas like I needed to dump basically second stage at full velocity, it did that. but once it pushed through max Q and it triggered main engine cutoff, something went bad at that point in time. I can watch, like if you have watched the live stream, I have linked the video down below. It's like they say main engine cutoff, but engines are still working. That should not happen, and that's why I specified. Turning that many engine on, it's a hassle. Turning that many engine off is also another hassle. So engine did not turn off, and the booster did not separate. Basically, the separation did not happen, and then it lost control and it just tumbled, and then it went boom. Basically, boom was a initiated command for safety reasons, but that's one of those things that happened. So multiple engine failure, this is the most clearest image I could find where you can see multiple, and I would urge you, watch multiple people's video. You will find like engines are literally, it's not like, oh, shut off or throttle down. No, engines are literally going boom, and like multiple parts are coming out, metal parts at very high altitude. So, and again, flame colors is also changing. So flat out, we know multiple engine failure happened. It's like started out with 3 and then it went as bad as 6 or maybe even 7 engine failure. So that's the first thing that happened. So why? Now, one thing you have to understand, I'm making this video way too early, so I do not have conclusive data at this point in time. Hopefully by the time you're watching this video, or maybe in few weeks after that, we should have a conclusive data. This is what happened, this is why it happened, all that. But at this point in time, all a point leads to this crater. Now, what is this crater? Well, this is the launch pad. There was no crater there. There was a armor grade concrete layer there, like armor grade concrete. I'm not talking like basic bitch concrete. I'm talking about concrete that are designed to work at metal furnaces. So even if you have metal, molten metal going on it, the concrete should be like, bro, I got this. But it did not get this. What the hell happened? Most likely the concrete strength was not good enough. Even though this is a, if I'm not mistaken, I have watched other people whose sole job was like concrete and all that. They analyzed it that SpaceX has upgraded the concrete from a basic standard to very high yield standard. Even that was not strong enough. So what happened is the moment it launched, which you can watch in live stream, is that there were multiple debris, and I mean multi-ton concrete splurting out. It's like, and those concrete, which mind you, this has happened in the previous launch also, where concrete literally damaged the engine. So if you have this size of crater, there is a very good chance a lot of debris directly went into the engine, which, like from an engine's point of view, it's like literally molten lava coming to you, blowing you up from the inside. And that's why the moment engine launched, this was the basically telemetry diagram where they had 3 engine failure. So that's the most likely reason why you had 3 engine failure from day one, like not day one, as in like the T1, the T0, you already had 3 engine failure. And lot of things went up there. Like this debris cloud it created was brutal enough where you're like, dude, it would be shocking if the rocket itself survives. The debris cloud was brutal. And lot of engine went up. Again, it started with 3 and it went more and more. However, at one point their telemetry data showed 1 engine coming back online, which it does not make sense, because you see so much plumbing here. That plumbing is for engine ignition and startup and spool up, meaning the engines cannot start on their own. The center engines, because those are designed for re-entry and designed for basically safely landing, they have circuitry, they have the plumbing, they have all the gas valves necessary for starting the system. Everything else, the piping is here. So if you see any outer engine turning off or turning on, if the engine is completely working, then you have a sensor failure, or if engine is off and this is showing that this is faulty, because fundamentally it cannot restart. The engines cannot restart once they shut down. See, only the core engines which are designed to be reignited, they have the circuitry to reignite. Everything else is just relying on this puppy. Once this puppy is launched, it's just go until your job is done, and then the core engines will save you safely. But that did not happen, so we had issues. So what is my estimate at this point in time? It's just guesstimation, nothing precise, nothing accurate. My estimation is, as it kept going up and up and up, it had to deal with more and more thrust vectoring, meaning not all engines have gimbals. Basically, they cannot do like this. Many engines do have, especially the core ones, but outer ones, they have throttle control, meaning they're gonna change your throttle. Now all engines supposed to be, if every engine was working, they had 70%, meaning the throttle had 30% plus range in every engine. But if all engines were like overworking, because again many engine failure already did happen, so maybe they do not have enough thrust vectoring on throttle level, and the core gimbals, they were working their ass off, because again, be mindful, there was a failure in the central engine also. So all of those things may created a scenario where there was too much thrust vectoring. Again, computer was trying its ass off to make sure the rocket is safe, but it may have created a scenario where too much torquing motion going on in the rocket, and it may have jammed basically the stage separation mechanism. Now, either software wise or electronically wise, we do not know. It will be known in later investigation, but something bad happened and something did cause a jam. Most likely candidate is the basically dirty thrust vectoring, so to say, and it lost control flat out after that. After that, it started to tumble, and engine was on. Even though MECO command was given, the engine was on. So it started to roll out of control. Boost back flip did happen. It did initiate boost back even though engine was on, and it still failed to do separation event. Rocket did not fall apart in air. Now be mindful, the reason could be twofold. First, it could be a strong rocket, or second, it could be that it was already too high up. Maybe it's like already at that point in time it's around 30 kilometers in altitude. So at that point it's partial vacuum. So that tumbling will not have created that much drag. So maybe these are two reasons that made sure that rocket stayed intact, quote unquote. And then the flight terminator system is like, bro, I liked it, you did your best, now you have to go boom, and it went boom. So that's the most likely reason. This should not be, like, these pillars are buried inside, they should not be exposed. And like there are other cars that are far away. I'm not talking like directly parked next to it, I'm talking something far away, like giant chunk of concrete is going by. So concrete was just like annihilated. So they have to do flame trench and they have to do water deluge system. This sort of naked concrete plank, yeah, no. That's a big ass nope. If you ever wanted to see a nope, that's a nope. So what we can expect in the future? Well, the first thing is it's going to take some time to reassess, because that concrete shower that it created, this puppy, that's brutal, because every footage that we are getting after the launch, everything is damaged. Everything. There are trucks that are poofed. There are cranes that are poofed. There are containers of basically liquid propellant and all that. Those have outer casing that are damaged. Hopefully internal casing is not damaged, but enough damage is there that even on normal footage you're like, bro, this is damaged, this is damaged, this is, oh, this is going to take some time, this is damaged. It's like hell, like everything is damaged. So it's going to take some very serious time, and launchpad need to be rebuilt. You cannot just have a crater there, or maybe they can use that crater to, like, create a flame trench, maybe, two in one. But it needs to be done. Like, they have to have flame trench, they have to have water deluge system. Like, this puppy sorts it out. It's like, you can try all that dong. It's like, put this concrete or that, or give this much altitude. It's like, no, just give a goddamn flame trench, just give a goddamn water deluge system and go home. So we need something like that. And all the pre-changes that they have already done on the system, those have to be collaborated with test data. They did got a lot of data out, so those test data has to go into the system, and we are like, this part I think we need to reinforce, or this part maybe it was too reinforced. It was like supposed to disconnect, it did not disconnect. Maybe all the feedback loop has to be done. So next build, even though they have physically the rocket, it will still take much longer time, because they are doing the feedback loop. Feedback loop does take time. So we are looking at minimum 4 months from now. Again, unless they have like absolutely damn sure, some engineer was like damn sure this is the faulty part and this test kind of proves him, then like maybe they could rush it. But I'm pretty sure they cannot have this concrete shower again and again. It did damage all the other things also, because like, let's say you're launching in middle of nowhere like Kazakhstan, and you have Russian rocket system, and because it's a frozen area, you cannot have water deluge system. You have a giant flame trench, and even if the rocket goes boom, nothing happens, because nothing is surrounding it. But when you're talking about Boca Chica, Starbase, basically, there's a whole rocket factory there, so you cannot just have like concrete shower on it. You just cannot. It's just like, nope, you cannot do that. So flame trench is one of those things they have to do, and water deluge is the easiest way to make sure the gas plume that it's creating is not as brutal. Because again, SLS should have bigger plume than this, but this had, I think, the biggest plume I have ever seen. Why SLS should have biggest? It already has the core hot exhaust from basically the core engines, and it has solid boosters. Solid boosters create very heavy soot, basically, very like fluffy cloud, quote unquote. This is not supposed to create fluffy cloud, and it created so much dust cloud that it's brutal, let's just say. So I would say relax, take a chill pill, wait for 4 months, then we'll know more. And this cannot go on. This debris cloud cannot go on. So this was my presentation on basically the Starship orbital launch test Mark 1. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment, because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.